Hi, it's Mr. Blystone here with video number 1 for unit number 1 of Precalculus, and this lesson is on solving systems of equations in two variables. So, from previous classes, Algebra 1 and maybe Algebra 2, you might remember that there are three good methods for solving systems of equations. We can graph them, we can use substitution, or we can use elimination. So let's look at an example. So solve the following system of equations. We have x plus y equals 4 and x minus y equals 2. There are two good ways we can solve this. There's substitution, there's elimination. Let's go ahead and do substitution first, because it's a method we don't always do. So let's just get that one out of the way really quick. Okay, so for substitution, what we want to do is solve in terms of one variable, at least one equation. And we can do that with the second one. We can say that x minus y equals 2 if we add y to both sides. We get x equals 2 plus y. Then we can substitute that back into our first equation there. So we can say that 2 plus y is equal to 4. Y and y combined to make 2y. 2 plus 2y equals 4. Subtract 2 from both sides. 2y equals 2. Subtract 2. Divide by 2. Y equals 1. So we can plug that back in. We can plug that into the second equation. Let's do it that way. So we can plug that in. X minus 1 equals 2. And I hope you know that x then would be x is equal to 3. So our answer is the point 3, 1. Now, that's not the only way we can solve it. We can solve by elimination. Let's look at elimination, how we'd use it. So this is x plus y equals 4, and x minus y equals 2. So the point of elimination is to combine equations, possibly having to do a multiple of one or the other, to get a variable out of the way, to cancel. In this case, all we have to do is add. So x plus x is 2x. Y plus a negative y, that cancels. 4 plus 2 equals 6. Divide by 2 on both sides. X equals 3. So we plug back into the first. 3 plus y equals 4. And I hope you see that y equals 1. Same answer as before, 3, 1. Another way to do it. So there's substitution and there's elimination. So why don't you try this problem? See which method you think might work best for you. I'll show you which method I like for this one. Pause the video, try it, make sure you got it, and then come back and see if you got the answer. Okay, I'm assuming you've paused the video and tried it, so let's just do it real quick. I like substitution for this one. I can add y to both sides and get x equals y, or y equals x, either way. So we'll just plug in this for 5x. We can say 5y minus 3y equals 6. We can combine like terms. 5 minus 3 is 2. 2y equals 6. Y equals 3. Okay, now we plug in. So x minus 3 equals 0. What minus 3 equals 0? 3. X equals 3. So our point is 3, comma 3. Simple, really easy. All right, let's move on. So now we have a different type of system of equations. This is a graphing system of equations, clearly, and it's not linear. We have the natural logarithm of x is equal to y, and x plus 1 equals y. So we probably should graph these. Or sorry, x plus y equals 1. Did I say x plus 1 equals y? Should be x plus y equals 1. I think we should graph these. We could try substitution, but then we still have to deal with natural logs and all, and I just think graphing might give us a better time here. So that's what I would do. So I'm going to go into Desmos, and we'll look how to graph them in Desmos. Okay, so here we are in Desmos. So let's graph our two equations. Our first equation was ln of x. Then our second equation, we'll add one, was x plus y equals 1. Let me just make sure that that was correct. Went back, made sure, yes. So we look at our graph here. The point they intersect is 1, comma 0. So what we'll do, we'll say our answer is 1, comma 0. All right, so we just graphed it on Desmos, and our solution is 1, comma 0. So let's look at another example. All right, solve this system of equations. 3x squared plus 4x minus y equals 7, and 2x minus y equals negative 1. So we have a parabola and a line. So the options here are that they could never cross, they cross at one exact point or 2 points. They're clearly not the same, so we won't have infinitely many solutions. So what I would do is get these into the form of y equals. So I would add y to both sides of each, and then I would subtract 7 and add 1. So I get 3x squared plus 4x minus 7 equals y, and I get 2x plus 1 equals y. So now, since we have them in both y equals, we can just set them equal to each other. So 3x squared plus 4x minus 7 equals 2x plus 1. Now we want to get this into a form where this side where the right side is 0. So I subtract 1 from both sides, and I subtract 2x from both sides. So I'm left with 3x squared, 4x minus 2x plus 2x. Negative 7, negative 1 is negative 8, and that equals 0. So now what I need to do is factor. If I factor this, I get 3x minus 4 and x plus 2. And we say that that is 0. Okay, so we solve these, each for 0, as we normally do. We get x equals 4 over 3, and x equals negative 2. So these are values for x we can plug back in. So let's do that. Let's plug that into our second equation, 2x minus y equals negative 1. So let's start with 4/3. So we have, let's remind ourselves of that equation, 2x minus y equals negative 1. Actually, I prefer the form y equals 2x plus 1. Makes it a little easier. So 4/3 times 2, so y equals 2 times 4/3 plus 1. 2 times 4/3 is 8/3. I hope you remember that 1 is 3/3. So that is 11 over 3, 11/3. So our first answer is 4/3, comma, 11/3. Our second answer, plug in negative 2. So y equals 2 times negative 2 plus 1, which is negative 4 plus 1, which is negative 3. So our second answer is negative 2, comma, negative 3. And that is our answers. Those are our answers for this set of equations. Pretty simple. All right, so of course, for these, there are 3 possible cases. We have that there's at least one solution. There could be 2, there could be more, there could be 1, or at least 1. That's a possibility. No solution. There's no solution. 2 curves don't cross, the 2 lines don't cross. They're parallel if they're lines. And then infinitely many solutions, the 2 equations are the same. All right, so if you want to try some problems in section 7.1, do 5 through 14, numbers odd, 15 through 18, and 23. And then 7.2, 1 through 22, and only the evens on that one. And then omit number 20 as well. All right, so I hope this video was helpful, and keep on learning.